Okay, so we're on number 1. You guys remember what domain means?
This is one of the 4 areas.
Huh?
Domain, range.
Oh,
Domain is like the x. Domain is like the x values. So on the graph, it's kind of tells you like how far left and right the graph goes, and the range is like the what?
The
Y values. I don't want to do that thing. The range is the y values, so that tells it on the graph it's up and down the y values. You guys remember how on the graph we can tell something is a function or not? Vertical line test, yeah. So, for example, like last chapter, all these things are functions because they pass the vertical line test. Anywhere I draw a vertical line, it's only going to go through the graph once. But if it was like this, that would not be a function because it fails the vertical line test. Each x value has to have its own unique y value. And like this, it's just like 2, 2, 2, negative 2. Okay, so on number 1, is number 1 a function, yes or no?
Yes.
Yes. Anywhere you draw a vertical line, it only passes through that graph one time. Okay, what is the domain? If it's not a function, I guess you don't have to say the domain and range, by the way. What is the, right, the lowest x value, if you go all the way to the left, what's the lowest x value? Negative 2. And what's the highest x value? How far to the right does it go? 5. So all the x values are everything in between because it's a continuous set of points. The line is not broken. So how do we say every x value between negative 2 and 5? Okay, x is greater than or equal to negative 2 and less than or equal to 5. That's what that says basically. So the range is the y values.
Negative 1 to 1.
So the y values tell you how far up and down the graph goes. The lowest y value is over here, and it is at negative 1. Okay, the highest y value is here, and it is at, was it positive 2? No, 1 is where it's crossing the y-axis at. It's a little bit off center. It looks like that, right? So this is a 2. So anyway, all the points from 1 to 2 are going up and down are filled in. So it's everything from 1 to 2. But this time, it's a y value. So I'm going to put that. Whoops. Negative 1 to 2. I'm forgetting something. Oh, why did I put or equal to right there?
Because it'll include.
Right, because like, yeah, the point 5 is included. So if this was an open circle though, I would not include 5, so that would just be a less than simple number, not an equal to. Okay. Number 3. So number 3 is not a continuous set of points. Is it a function? Does it?
Yeah.
Yes. Anywhere you draw a vertical line, it will only hit at most 1 point. So yes, it is a function. What's the domain? Maybe
0, 6.
0, 2, 4, 6. So the point on the left has an x value of 0. The second point has an x value of 2 to the right, 4 to the right, 6 to the right. So it's 0, 2, 4, 6. Okay, the range is the y values. So what's the y value of that lowest point? 0, 0, 0. What's the y value going up the step? 1, 2, 3.
Leo's gonna have to watch the video a few times.
Too late now. Mm-hmm. Yeah. You can, yes.
Are you using quadratic formula?
Saving it. Something to look forward to. All right. Is number 4 gonna fool you guys? Wrong one.
No.
Huh? I'm still bitter, Lydia, by the way.
Oh, sorry, my bad.
On number 5, is that a function?
No.
No. Why is number 5 not a function?
Because it does not pass vertical line.
Yeah, if you draw a vertical line, it hits the graph twice. If it's not a function, it does still have a domain and range, but
You don't.
the book said you don't have to do it, so we're just going to skip that part. On number 6, what do you guys think the domain would be?
Negative infinity to infinity. All real numbers.
Okay. It is all real numbers. So some books, by the way, I've seen this on some of your homeworks. There's like 2 ways you could get this answer, or an answer like this. That's if you have a tutor, or if you use the app on your phone. Okay, because we did not learn this method. So whenever I see this, sometimes I get cranky and it's kind of wrong. These kind of mean the same thing. This is from negative infinity to infinity. Same thing as all real numbers. Different books have that. Use this. Our books use that. Okay, anyways. Number 7. Explain why the equation x squared plus y squared equals 1 does not define y as a function. Why is that not a function? This kind of goes to number 8 too. 8's kind of the opposite of number 7. Number 7, if we graphed it, we did this in geometry once. I don't remember if we did it in algebra 2. But does anybody remember what the graph of x squared plus y squared looks like? I can't remember if we talked about it in algebra 2. It turns out x squared plus y squared, they're circles. So the reason they're not functions, well, you could say it fails the vertical line test, but for each x value, most x values have 2 y values that go with them. Okay. Like this might be 1 square root of 2, whatever. So it's because
Circle Sam. You just looked at me like I shouldn't say it. You should. Okay. But it's a circle Sam. I won't say it. I won't say it.
all right, so that's basically the answer. Each x values has a couple y values, except for the very edge. But I'm not going to write that part down.
On 8,
So if 8 is a function, it would be because why?
Because there's only one x value for one.
Each x value has one y value.
So what does that make 8?
We were just talking about it.
I'm sorry.
Okay, so if number 7 is not a function because each x value has a couple y values, then why would number 8 be a function?
Because it doesn't have a couple.
Right, or it just has one, each x value has one y value.
Okay.
What does the graph of x cubed plus y cubed look like? Anyways, number 9, give the domain of the function. So what values can x be? Normally the domain is unlimited. It could be all real numbers. But when there is an x in the denominator, you cannot have what in the denominator?
A variable.
No.
A negative.
No.
Square root of 0.
Girls.
Square root of x.
No. 0. You cannot divide by 0. That's a no-no.
Good job.
So x can normally be anything, but anything that makes the denominator 0 is a no-no. So on 9a, what can x not be?
1. Oh shoot, 0.
You said it with such confidence.
1.
Okay. On b, it's 1 over x minus 9. So what can x not be?
9.
So basically it can be every single possible number except for 9. That's what that means. This one's a little trickier. X squared minus 4.
2. It's also 3x on top, I'm pretty sure.
Yeah. Why is it plus or minus 2?
Square. Because it's a square.
Okay? It's basically factoring. X cannot equal 2 or negative 2. So
I'm always going to miss that positive number.
Oh,
No
yeah.
matter what I do.
I
So
just-
you dropped your roll, I'm pretty sure. Glad I didn't do it.
I've given up on you soon. Okay. Number 11, give the domain range and zeros.
Oh. That's not good.
I might have to help you guys on 12 too. Do you guys remember what if we think about what the graph is, it might be easier to do these. You guys know what the graph of square root of x looks like? Or sorry, absolute value. I was looking at number 12. Absolute value of x looks like?
Problem?
Come on now, we did this last year. No, it's not an x. Okay, well, you guys are gonna have to do it the long way. I mean, it actually wasn't the worst guess in the world. If I plug in negative 2, what do I get?
2.
If I plug in negative 1,
1.
if I plug in 0,
0.
okay, negative 2, 2, negative 1, 1, 0, 0, 1, 1, 2, 2. What shape is it?
Parabola.
No.
V.
A V.
Um,
I hate being off by 1.
Okay, anyways, so the question is, what is the domain?
Positive numbers.
Okay, what does domain tell us again? X values. What X values are included? All of them. I'll do the fancy R. Okay, yeah, the Y values, the lowest Y value is down here at 0. What's the highest Y value?
All of them.
Infinity. So if you do it the other way, it would be like from 0 to infinity. This means 0 is included, and infinity you can't ever include because you can't reach it. But 0 to infinity. So how are we going to write that? No. All these numbers, all the negatives are not included, right?
Right, so y is greater than 0?
Can it equal 0? Yeah, greater than or equal to 0.
I hate it so much. Just give it to me, please.
Okay, the third question was, what are the zeros of the function? You guys remember what that meant?
What makes it 0?
What x value makes the function 0?
0.
0. All right, B, what is that minus 2 going to do to the graph?
Go down to.
No,
Move it right up.
right 2.
Wow.
You guys forgot all you knew from last year, huh? Well, we're going to remind you. So it's pretty much the same graph. The vertex is just at 2, 0. And it goes up like that.
So wouldn't it be nearly the exact same thing?
Almost the exact same thing. What's the domain?
All numbers.
All real numbers. What's the range?
Greater than or equal to 0.
Still greater than or equal to 0.
And then x equals 2. Yes.
Yeah. The 0 of the function is now 2 because 2 minus 2 is 0. Oh, wow. Some kind of Owen Wilson when you said that. He'd shut it. Okay, so what does this do?
Down 2.
Down 2. Sam, you missed your moment of glory.
No. Come on. Sam, just wake up. I can't.
All right, what's the you don't. By the way, the graph's not the answer. I'm just drawing it so we can
See.
imagine. Domain.
Why is greater than or equal to negative? What? That's all real numbers.
All real numbers. Going left and right forever. Range.
Why is less than or greater than or equal to -2?
Yes. -2 and above. So y is greater than or equal to -2. Zeros of the function.
Plus or minus 2.
Right. If you plug in +2,
I actually knew it was positive.
you're going to get 0. If you plug in -2, right there, you're going to get 0.
I think I need to go home. I'm not going home.
I probably better have a 12 because it's a bit tricksy. Does anybody think they remember what square root of t or x or whatever looks like?
Trey, you got this one.
We have not done this year, but we did it last year. Okay. Well, what if if I try plugging in like -1 right there?
Be an imaginary,
Right, so it's kind of like
no negative.
doesn't exist, basically. So could I plug in 0? Square root of 0?
Zero.
0. 0 times 0, 0. Yeah, it works. 1?
One. Not two, but.
Okay,
two,
you could plug in 2.
but.
What would it be?
Square.
Square root of 2. It's about 1.4. It's a weird decimal, but 4,
2,
9.
3. Sound like well.
Is Will talking to you guys yet? Is he forgiving you, Trey?
I actually had one conversation with him last night.
What?
It was the first one.
No
Where
way.
is he met? Where is he?
Last night or Friday
Because
night?
Trey
Last
is
night.
weird as.
Why is
Oh
he
yeah,
met?
United.
I don't know, he just wanted to talk to
Will
me.
talks to me literally every day and tells me how we have
Wouldn't that be funny if he just thought you were annoying and he...
I mean, that bothered me.
No, Will talks to us all the time.
Yeah.
That's actually probably it.
Wouldn't be surprised. It's probably like in his room, he's like, Trey is just such a low intellectual human being.
I had that
I
ask.
cannot form a conversation with him.
You sound formula.
Actually,
I'm a son of a human.
the way we all were wondering, and I had to answer the question because
I don't care.
Okay, so here's the picture. The negatives, nothing works out there, so nothing's going on out there. So what would the domain be? Remember, domain is x values,
Greater than or equal to 0.
right? The lowest x value is 0, and then it goes forever this way. So x is greater than or equal to
Would
0.
it be the same with range?
Is it the same with range?
Yes.
The lowest y value is 0, and it goes, yeah, forever up. It does go pretty slowly up, but that doesn't matter. It's still going up. Like the square root of 1,000,000 is 1,000, so it'll only be up to 1,000 once if you go out 1,000,000. Square root of 1,000,000,000,000 is 1,000,000. Anyways, what are the zeros of the function? 0. You can kind of tell on the graph, but I guess it also says it right here. When x is 0, the function is 0. So x equals 0 is the 0 of the function. Okay, on B.
Whoa.
Kind of hard to describe what that's going to do. The negative on the t, when you put a negative on the variable, it does a horizontal flip like this. I just thought of the Beyonce. Not the dance, but yeah. No thanks. And then if you add 9, like on the variable, it moves left to 9. So let's what y values could we plug in here?
9.
We could plug in 9. Could we plug in 10?
Yeah. Wait. No.
No, because that would
There you
9 minus 10 is -1,
go.
and the square root of a negative is imaginary, so you can't have that. So 9 is the biggest thing we could plug in. So let's, could we plug in 8 for t? 9 minus 8, that would work. Could we plug in like 5 for t? Yes. Okay, so if you plug in 9, what do we get if you plug in 9 in there?
0.
Yeah, 9 minus 9 is 0, so that is 0, 0. If we plug in 8, 9 minus 8, 1, square root of 1. Plug in 5, 9 minus 5,
4.
square root of 4,
2.
2. So let's see what this looks like. I'm going to kind of cheat here. 9, 0, 8, 1. Let's say 5 is about there. 5, 2.
So it looks like for x is less than or equal to 9.
the domain x is less than or equal to 9.
And then y is greater than 0?
Yeah, it's kind of like the last one. We're starting at the x-axis going up, so it's y is greater than or equal to 0. And what was that? Oh, the 0 of the function. 9. To find the 0 of the function, you set it equal to 0 and solve for x.
It was about to sneeze.
It's annoying. So close. Alright.
It's great to have water, Sam. Isn't it great to have water?
I love water so much.
Don't distract. Okay, so what t values could I plug in on this one?
0,
Okay, 0 would work,
3,
3 would work.
2. No.
Okay, yeah, 2 would work. Okay, what can I not plug in? Maybe we should talk about that. 4 would not work. How about, because 9 minus 4 squared, that's gonna be negative. What about negatives? Can I plug any negatives in here?
Nah. It's squared, so they won't do it.
Like if I plug in, let's say, -1, what would that give me? It'd be 9 minus, by the way, that reminds me, some of you did this wrong in the test.
Yeah, look away.
Suddenly Leo's paying attention. I might be thinking, actually I might be thinking of a different class's test, I don't remember. No, I think it was recent. This negative right here, is it squared? No. So, yeah, some of you, I think, were squaring the negative. And anyway, if you plug in -1, it looks like that. So 9 minus +1. Anyway, you can plug in negatives. It'll work. So we could plug in -3 as well. Anyway, let's see what happens. If I plug in 0, what am I going to get?
3.
3, yes.
Yes.
9 minus 0 is 9. Square root of 9 is 3. If I plug in 3,
0.
9 minus 3 squared is 0. If I plug in -3,
0.
yeah, just like this. 9 minus 9, basically. So let's see what we got. You would kind of need some more points to kind of figure out what's going on here, but this is what we got so far. Okay, what shape do you think that is? You probably guessed wrong. It's a semicircle. Now, remember we said we can't plug in like anything bigger than 3, right?
Right.
So there's nothing going on out here. Like nothing out there, or nothing less than -3. Anyways, what's the domain?
-3 greater than or equal to x with greater than or equal to 3.
Less than or equal to, yeah. -3 is less than or equal to x, less than or equal to 3. All the x values from -3 to 3. What is the range?
0 to 3.
0 to 3.
I got one.
It's time to retire.
Get it.
I'm done. I'm not gonna say it.
Okay, what was the last question? What are the zeros of the function? Yeah, positive 3 and negative 3 make the function 0. Alright. That doesn't leave a lot for you guys.